All right, so here we go. All right, so A, simplify the following by finding common denominator, then use the fundamental identities to simplify further. So again, you're following directions. So this becomes 1 times 1 minus cosine x plus 1 times 1 plus cosine x over the product of those, which is 1 plus cosine x, 1 minus cosine x. All right, equals, when I distribute, 1 times 1 is 1, 1 times 1 is 1, 1 plus 1 is 2. The negative cosine x plus cosine x cancels out over 1 minus cosine squared x. Everybody good thus far? 1 minus cosine squared x using your Pythagorean identities is sine squared x. And since that's in the denominator, 2 cosecant squared x. Similar idea with number 2. We're going to take the 1 and multiply that by secant x minus 1. And we're going to minus 1 secant x plus 1. Put that over the product, which is secant squared x minus 1. Secant x minus secant x, once again, cancels out. 1 times negative 1 is negative 1. Negative 1 times 1 is also negative 1. So I end up with negative 2 over. Now I'm looking at secant squared x minus 1. Tangent squared x plus 1 is equivalent to secant squared x. If I move that 1 over through subtraction, I'm going to have tangent squared x equals secant squared x minus 1. As a result, I can write this as tangent squared x since that is equivalent. And then since it's in the denominator, negative 2 cotangent squared x. All right. Number 3, the first term does not have a denominator, so we're going to multiply that by the other denominator. That would give us tangent squared x over tangent x minus secant squared x over tangent x. The net result would be tangent squared x minus secant squared x over tangent x. I then go back to the Pythagorean identity, which is tangent squared x plus 1 equals secant squared x. All right? And basically try to rewrite this so it looks like my numerator, which means I'm moving the secant squared x over there and the positive 1 over there. The net result is tangent squared x minus secant squared x equals a negative 1. Everybody good with that idea? So that means this becomes negative 1 over tangent x, which when I'm done is negative cotangent x. Alright, next one's going to be there's a couple ways we can go about it. I can start by doing tangent x times 1 plus sine x plus cosine x over 1 plus sine x. Alright, you'll realize that's going to get very convoluted. So the idea is to rewrite tangent x as sine x over cosine x plus cosine x over 1 plus sine x might be a better approach. You're then going to have sine x times 1 plus cosine x plus cosine x times cosine x over cosine x 1 plus sine x. I'm then going to distribute up top. I know what I did. That should be a sine x. Sorry. So then this becomes sine x plus sine squared x plus cosine squared x. I apologize. Now I'm focusing on this. My Pythagorean identities, what is sine squared x plus cosine squared x equivalent to? Rhymes with fun. So hurtful. Sine squared x plus cosine squared x is equivalent to 1. What do you then notice about your sine x plus 1s and your 1 plus sine x? What are they going to do to each other? Cancel out. And you got 1 over cosine x, which at the end of the day is secant x. When finding a common denominator, you can always get away with multiplying by the opposite denominator. So I can take cosine x times cosine x. That'll give me cosine squared x. Plus, now I'm going to multiply 1 plus sine x times sine x plus 1. Please don't forget that you have to FOIL it out and distribute when you multiply it through all over sine x plus 1 times cosine x. Notice I am not distributing in my denominator. Again, cosine squared x plus sine squared x is equivalent to 1. 1 plus 1 is 2. So 2 plus sine x over sine x plus 1 times cosine x. What number do both of these have in them? 2. I can pull that out. What does the 1 plus sine x and the sine x plus 1 do to each other? Cancel out, leaving you with 2 over cosine x, which is the same thing as 2 secant x. Same thing with number 6, tangent squared x plus secant squared x plus 2 secant x plus 1 over tangent x, secant x plus 1. I'm going to put together these two, because that's an identity. 1 plus tangent squared x is secant squared x. So I got secant squared x plus secant squared x plus 2 secant x over tangent x, secant x plus 1. This becomes 2 secant squared x plus 2 secant x over tangent x, secant x plus 1. Pull out the 2, secant x, and I got secant x plus 1. Secant x plus 1s cancel out, giving you 2 secant x over tangent x. That is going to be equivalent to 2 secant x, cotangent x, secant x is 1 over cosine, cotangent is cosine over sine, cosine x cancel out, leaving you with 2 over sine x, which is 2 cosecant x, when you're all done. Alright, the second and final part of working with fractions is rewrite each expression so that it's not in fractional form. Alright, then simplify is what the instructions will say on Wednesday. Just letting you know. Alright, so when you have a single term in the denominator, all you're going to use is either reciprocal or quotient identity to change that. So the first thing I do is this becomes sine x, cotangent x. Then using your quotient identity, sine x times cosine x over sine x. What then do the sine x's do to each other? Cancel out, and you're left with cosine of x. Cosecant y, cotangent y. Becomes cosecant y, tangent y. Everybody good with that? Cosecant y is 1 over sine y. Tangent y is sine y over cosine y. The sine y's are going to cancel out, leaving you with 1 over cosine y, which is equivalent to secant y. Number 3, we can go 2 routes. Route number 1 is rewrite sine squared y as 1 minus cosine squared y. We then factor that as the difference of 2 squares. So that becomes 1 plus cosine y, 1 minus cosine y, over 1 minus cosine y. The 1 minus cosine y's are then going to cancel out, leaving you with 1 plus cosine y, and it's not written as a fraction. The second approach to these type is you can multiply by the conjugate. Tangent squared x, cosecant x minus 1, over cosecant x plus 1, cosecant x minus 1. The top, I'm going to leave without distributing tangent squared x, cosecant x minus 1. The bottom, because of the conjugate, becomes cosecant squared x minus 1. By Pythagorean identities, tangent squared x over tangent squared x, cosecant x minus 1. The tangent squared x's are going to cancel out, leaving you with cosecant x minus 1. You have those choices because you have trig functions in both the numerator and the denominator. In numbers 5 and 6, you don't have that choice. Alright? Because you only have a constant in the numerator, now you got to do the conjugate. Again, do not distribute, because chances are something's going to cancel out somewhere down the road. Alright, this becomes secant squared x minus tangent squared x. I go back to my Pythagorean identities. Tangent squared x plus 1 equals secant squared x. So to get it to look like that, I'm going to move the tangent squared over, and that simply becomes 3 times secant x plus tangent x over 1, giving you 3 secant x plus tangent x. Your choice if you want to distribute or not. Same thing with number 6. The only difference is the conjugate is the negative, so I'm going to multiply by tangent x minus secant x. I'm going to have 5 tangent x minus secant x over tangent squared x minus secant squared x. The only difference between that and that, which is 1, is it's in the wrong order. So to account for that, instead of putting it over a positive 1, we said we put it over a negative 1. And as a result, we have negative 5 tangent x minus secant x. And your choice if you want to distribute it or not.